GeoServer and GeoWebCache and some of the difficulties and challenges and so forth that go with that. I think it's worth mentioning that I don't think I'm going to blow your minds with like some revelatory clustering design. I think the design is actually fairly obvious once you start walking into some of the problems that you will inevitably walk into. But what I think I can do, as opposed to blowing your minds, is to give you some of those considerations and some of the benefit of the knowledge that we've generated at Ubisense over the last couple of years doing this for some of our customers. So that's kind of what my goal is today overall. So what this talk is about is basically just walking you through the reasoning and the process involved with scaling GeoServer and GeoWebCache, including like why would you begin scaling in the first place? What are you trying to address? And then what things do you need to consider when you're doing so? And those things will inevitably drive your design. What this talk is not about, however, is about how to tune an individual GeoServer instance. And it's not to say that this is really not an important and complicated topic, because it is. It just so happens that this has been covered a number of times at previous FOSS4G conferences. And if you Google GeoServer on steroids, you'll find that there's some really good slides out there that will already kind of guide you on how to go about tuning GeoServer and GeoWebCache. So I'd suggest you do that if you're interested. I will discuss maybe a couple GeoServer parameters, but only insofar as they affect clustering and so forth. So at Ubisense, we use GeoServer a lot. We have a product called MyWorld that's able to consume lots of different data sources of different types, and we do so in a variety of different ways depending on requirements. Sometimes it's driven by nightly batch processes that extract data from one GIS system using an ETL. And other times we use GeoServer in order to serve those data sources up to MyWorld. And so we have a lot of experience with that. And the customers that we tend to have are serving up like outage data, Wi-Fi status data from telcos and from utilities, leak data for water companies and so forth. So this list is just a list of events that I could imagine that would drive you towards scaling and clustering. And I fully realize that some of the items overlap each other or encompass each other, but I thought I would state them anyways, since in terms of high-level requirements, customers often come to us with a variety of different problems that they're having, and they can be couched in different ways. And so here's some of the ways that they've been couched in the past. Obviously, poor application performance. So when you're rendering a GeoServer layer, you're not getting the performance of rendering that you'd like to have. Your GeoServer machine resources are being exhausted, and that can either be the CPU or the RAM. You're adding new users to your system, so obviously that would impact the application. You expect that to expect that to impact your application performance or your server resources. Adding new layers or feature layers or layer groups. Obviously that's probably in lockstep with adding new users. Same with spatial applications and adding new spatial data sources. It's also the case that you might have to consider clustering and scaling if you have requirements that are forcing you to render layers at higher scales than what they would have been normally. So what that'll end up doing is put more load on your GeoServer instances, and so it might force you to actually scale. And then one interesting kind of side note is we're actually doing a cluster at one customer site precisely because our nightly ETL process uses the GeoServer cluster in order to generate SQLite tiles that are then loaded out into the field. So there can be a whole variety of different reasons that would drive you towards clustering and scaling. But pretty much all of those reasons will ultimately be impactful in such a way that they impact some performance or hardware requirements. So number of users, i.e. the number of tile requests, would be one. They might impact your hardware capacity, whether that be GeoServer, GeoWebCache, or your database. And obviously a database here is a pretty big circumscription on what kind of performance you can ultimately get out of a cluster anyways. Network capacity would be another. Database structure is actually really important to the kind of performance you'll ultimately get from GeoServer. And there's some trivial examples I'll give you on a couple in a next slide on that one. And then feature density, which I'll return to again later. So the database structure, so that's, i.e. the structure of tables or table spaces, that can affect the rate at which you can render data onto a tile. A really poor example, but an example nonetheless, is if you had a feature table that was lacking a spatial index. And you can imagine that when GeoServer is rendering a tile, it goes with a box that it needs to render within. And it has to use a spatial coordinate in order to determine what features are going to be displayed there. Well, you can imagine if they didn't have a spatial index, that would take a lot longer. In PostgreSQL, if a table needs to be vacuumed, at times that can affect your performance as well. So database structure here is important to whether you might have to cluster or scale. Obviously, you could clean some of these things up in your database, but there are times where you really can't make a change, and in that case, you would just have to start scaling out. Feature density is important to your architecture, and that essentially means the number of features per tile. The more dense those features are, the longer it takes to render a tile. Typically, that's partially the reason, or a big part of the reason why it's not a good idea to render tiles at scales that are too high up. It increases the feature density to the extent that it can slow down the server cluster. Okay, so just about anyone who's played with GeoServer has probably started with this architecture. It's essentially the simplest one you can have. And all you've got there is a GeoServer instance running its bundled GeoWebCache, an application server, and a database server. And the application server could be something like Django or Ruby on Rails or whatever. And then you've got your database server, and that could be PostgreSQL or MySQL or Oracle or whatever in that case. And then, you've got your single GeoServer instance and GeoWebCache bundled within. Quick side note on terminology. GeoServer obviously can be scaled across machines, and that's kind of why we're here. But it can also be scaled into a machine. Now, a lot of talks about clustering talk about, well, you only really want to build a machine out, and with a lot of VM environments these days, that's easy enough to do, but you only want to build a machine out to the capacity that you need to serve up whatever software or to support whatever software you're going to install. A lot of times that's not an option. At customer sites, they have specific specs, and so a lot of times you'll end up with hardware that is too great for what you're trying to install. In that case, scaling in makes sense. So when we're scaling across machines, let's call that scaling out. And when we're scaling into a machine, adding GeoServer instances and containers, we'll call that scaling in. GeoServer on steroids, again, that talk I mentioned that you can Google has some content on how to go about scaling in. It's a problem that we've dealt with a few times, and I have some data at the end where I walk through some simple benchmarks, in which case I wrote some Linux initialization scripts that allow me to kind of toggle the number of sessions that I started on a specific machine. So if you need help with that, feel free to email me. Okay, so a next step, so we started out with this really simple architecture where we've got a single GeoServer instance and an application server and so forth. Now we've determined that we don't have enough capacity and we need to add more. The next obvious step is just to add another GeoServer instance. And this is actually quite effective. It's also the easiest step to make, but it has some issues. So in theory, we've doubled the capacity of our architecture. In practice, that's not actually going to be the case. The primary reason for that is it's really hard to balance the traffic between the GeoServer instances, right? So often case when you have an architecture like this, what's responsible for doing the balancing is actually the application server. So the application server, when it returns an address to the client and the client goes back to one of the GeoServer instances, it's been given that address by the application server in that case. And so you may not be getting an equitable balance between the two instances, in which case you need to deal with that. It's also the case that configuration data isn't being shared between your GeoServer instances. And when you only have two, this isn't so much of a problem. But if you had 3, 4, 5, this becomes a real issue. And this also assumes, of course, that you're not having different layers served up by different GeoServer instances. This is something you can do, and it's something that I've done before too. It has its own problems, and I will try to enumerate them in a few minutes. But so I'm not assuming that. I'm assuming every time you make a configuration change, you have to change it on each server, and that's a problem. It's also the case you have your tiles being cached twice, or 3 times, or whatever. And that doesn't sound like such a big problem. It's obviously a duplication of effort, but it actually does become a problem when it comes to expiring tiles. An expired tile, in my terminology, is when the content is no longer valid. So imagine that you have an outage that has since gone away, and you need that tile to be dispensed with, right? If you have that tile being cached across 5 or 6 machines, that becomes a serious problem in terms of getting rid of it so all your users have the same view on the data. As a quick aside, and this is a problem I've had to deal with a lot of different times, there are kind of 3 approaches that we've settled on. GeoRSS, which, to be perfectly honest, I have not used and did not like the documentation I found on it and was afraid of going down that path and wasting a lot of my time. Bulk layer clearing, and this makes sense when the content entropy is low enough, you can clear the entire layer. It obviously becomes a problem if you're talking about data that's refreshed every 15 minutes. In that case, if you bulk clear your layer cache, you really don't have a cache, right? So that's not a solution for everything. In the cases where we have had layers where the data has a high entropy, what we've often done is targeted layer cache or clearing. And what that amounts to is knowing which features have changed from minute to minute. And we essentially wrote PostgreSQL PostGIS functions that would tell us the exact tile that needs to be deleted in order to refresh that data. That's a pretty effective way to go about expiring tiles, as a matter of fact. So I've kind of alluded to this already. There's kind of a lifecycle spectrum on tiles and the content that they display. Obviously, there's kind of a real-time status, like outages, SCADA stuff, Wi-Fi status, vehicle position, things like that, and all the way down to things like daily, where you're refreshing the content daily and you need to expire those tiles. Obviously, real-time and near real-time and even near daily may not be good candidates for bulk clearing, whereas daily may be a good candidate for bulk clearing the layer. Finally, you've got low entropy content, which really doesn't drive you to any real decisions on how to clear tile layers because they're refreshed so infrequently that it's not a problem no matter what you do. Most applications that we've dealt with have content that's all over that spectrum, which means that it's not enough to design a cluster and just think about how many layers you have. What you really have to do is dig in enough so that you know what kind of content you're dealing with, how quickly it's going to turn over, how often you're going to have to expire tiles, what kind of load that's going to put on your servers. And so I mention this because it's just not enough for a customer to come to you and say, you know, here's what I have and here are the number of layers I display. You have to actually understand their data to an extent that can actually help you understand what kind of load is going to be put on your servers and how expiring is going to happen. Ultimately, whatever you decide to do for your GeoServer and GeoWebCache, that architecture is going to be driven by that lifecycle, the amount of data you're going to be serving, the amount of time needed to render the tiles, and this goes back to database structure, feature density, things like that, and the number of users that are requesting GeoServer and GeoWebCache tiles. So I kind of mentioned earlier that it's difficult to balance layers across machines. To decide, well, I've got 2 GeoServer instances, and I'm going to load balance by deciding to serve layer A from one machine and layer B from another. This table on the right-hand side of this slide actually is something that I generated at a customer site trying to do exactly this, trying to balance the layers out. And you would think by looking at this that, yeah, I'll just balance the percentages out here, and if I put, 50% on one server and the other 50% on the other, Bob's your uncle, I've got an equitable load balance. I want you to not think that way. It's a mistake. What you see from the refresh cycle there is that the node health is only being refreshed daily. So you can imagine that it's getting a much more positive impact from the GeoWebCache that we're using. The status of accounts layer, as an example, though, is being refreshed every 15 minutes. So odds are that's putting a lot more load on your GeoServer instances than the node health layer. So my guess would be, and this is not a scientific analysis given what only data we have here is what you see, is that status of accounts may be a bigger problem than the node health layer. My overall point here is not that this can't be solved, it's that this is not enough information for you to make that choice and to make you skeptical that balancing the layers across GeoServer instances is something that you can do effectively and easily. I want you to not think that way because, not there yet. So ultimately what you're trying to determine anyways for these guys is how long does it take to generate the tiles for this particular layer during a given day. And I call that total tile output time. That's a really hard statistic to come up with as part of the problem. And it may vary by day, by the time of day even, if you have different user groups that are popping onto the servers at different times. So I've never found this approach to be one that I would want to go down. So what I tend to want to do is to try and find something to do the load balancing work for me. And so in architecture 3, what we've done is put a load balancer in front of the GeoServer instances. And of course, I have 2 displayed here, but that could be 3, 4, 5, whatever. And so what we were able to do here is mediate the traffic between the GeoServer instances and remove that project of trying to figure out how your layers are being served and all that from your hands and make it easier to actually achieve an equitable balance. The application server in this case, again, that's Django or Ruby on Rails or whatever, it's instead of giving the client back the address for a GeoServer instance, will instead be handing back an address to the load balancer. The theoretical capacity here hasn't changed, but our ability to leverage that theoretical capacity has. The load balancer could be mod proxy balancer under Apache, and the benchmarking I do later, that's what I used, Nginx. Big IP, Barracuda. We have customers that are using F5. Those are all possibilities there. Even though we've made a substantial improvement on being able to leverage our theoretical capacity, we still haven't dealt with a few problems. One is the configuration data is still a problem. It's not being shared between your GeoServer instances. So again, if you have 4 or 5 of them, it becomes a problem. And then again, we still have the data being cached twice, and we still have this expired tile problem. So architecture 3 is an improvement on architecture 2. We've eliminated one problem, but we still have these lingering issues. And so architecture 4, I'm trying to take you through these as slowly as possible and repeat myself as much as possible. But architecture 4 deals with one of these problems by NFS sharing the GeoServer data or config data. So we've only made a minor change here, but we've designated one of the servers as the writer and the rest as the readers. The writer will have the physical data stored on its drive or some drive that it has mapped, and the readers will all just NFS mount that data and be able to read that data at any time. You could use, instead of NFS here, you could use rsync. There's actually a variety of different things you could use to sync that data across those servers. I used NFS, and there have been certain instances where I've wanted to use rsync, but they're all possibilities. It just needs to have some mechanism for getting the data from the reader to the writer. The web administration interface on the reader should probably be disabled in that case, and you can do that by setting a Java environment variable or by removing the jar file for the web administration interface. Again, this problem, going back to the issues, we've eliminated one, but we still have the other problem of having the tiles being cached twice. The configuration data is being shared, but each time that data is being changed by the writer, you still got this issue where the subordinate GeoServer instances need to be told to refresh themselves from their configuration data. And if you only have, again, one GeoServer, you can just log in and do, tell it to reread its configuration data. But that's not all that useful if you have 4 or 5 of them. This problem's pretty solvable, though. Here's a little bash script that I wrote at one customer site who had all their GeoServer instances named on a particularly formulaic scheme. Imagine it's GeoServer 01, 02, 03. It loops over numbers between 1 and 20. 20 servers don't exist. They had 5, but I imagine that they might want to expand at some point. It puts together what it hopes to be a host name and then pings it. If it finds it, then it goes ahead and submits a curl request using the REST API for GeoServer and tells it to reload its configuration data. So that last problem is actually not really a problem if you just invest a little bit of time in the bash scripting. Okay, so now we're going to eliminate the final problem and get to what looks to be the final architecture here. And so what the problem was that we were trying to eliminate in this case is that we were caching the tiles in multiple locations. So in that case, what we're going to do is put GeoWebCache in front of the load balancer. And so now we're going to have a single cache location for all of our tiles, and that'll be in that GeoWebCache instance. So we have a single unified cache. GeoWebCache, when it wants to get a tile, so a client comes to it and asks for a tile, it doesn't have it. Now instead of going to, now what it's going to do is instead of going to any individual instance, it's going to go to the load balancer, get back an address for GeoServer instance, go to that server instance and get its tile and put that into its cache. So GeoServer is essentially stacked in front of the load balancer. I didn't put it in the diagram, but it's worth noting the clients can still reach the load balancer itself. So that means if you have a fully dynamic layer and don't want to have GeoWebCache mediating any of the traffic, you can always point a client at the load balancer itself and not at GeoWebCache. But more often than not, you're going to have them pointing at GeoWebCache. I would argue that this architecture at this point is probably fully poised to exploit the maximum amount of tiling capacity that you have available. You're caching your data in one place. There's no duplication of effort. You're scaled out across your GeoServer instances. I think this is close to the endpoint, at least for what I've got anyways. It still has a couple minor issues. One is GeoWebCache has its own configuration data that needs to be maintained. And unfortunately, it's nothing like the GeoServer configuration data. It's a single file, a single XML file. If you guys have ever looked at GeoServer configuration data, it's a bunch of XML files spread throughout a directory structure that frankly takes a little while to get used to looking at and understanding. But yeah, so that's an issue. You can't just point GeoWebCache at GeoServer configuration and then have it understand what to do. It's also the case that when you make a configuration change to a GeoServer layer, imagine you change the symbology or you add a condition on which symbology to display. In that case, you have to clear your GeoWebCache so that those tiles are expired. And there's no easy way to do that given what we've kind of shown so far. But these problems are also solvable and also through scripting. So I'm not going to go through this in too great a detail, but this bash script essentially looks through that GeoServer configuration data for the files that are going to contain layer configurations. And whenever it gets a hold of one of those files, it pulls out the workspace name and the layer name, and then it builds a string that's going to contain essentially an XML string that GeoWebCache can read, and assembles that all together. After it's done, you can see that we go into a Python portion of the script where it's essentially just going to write out the GeoWebCache XML here. And here's the write instruction there. And then the last step in this portion of the script is to tell GeoWebCache through its REST API to reread its configuration. So now GeoWebCache knows about the configuration, or you would probably only do this in the case where you're adding a layer or something like that or deleting a layer. Now GeoWebCache knows about that change. The last step in the script is actually to run through those GeoServer configurations, and this is just a bit of a heuristic here, but we're looking for any GeoServer configuration change that's been changed in the last 2 hours. And whenever we find one of those, we pick out the name and the workspace name, which will tell us what the directory name is for that layer's cache, and we delete that cache from the GeoWebCache. So now we've basically closed up those two problems. We've got GeoWebCache refreshing its configuration from the GeoServer configuration data, and we're clearing GeoWebCache layers that may have changed due to some kind of configuration change in GeoServer. Okay, so that's the endpoint for that I think a lot of customers are dragged to ultimately, given these types of requirements, the requirements of expiring tiles, the performance requirements that they have, all that sort of thing. There's some additional, I guess, thoughts that need to be had when you're stepping from a single instance of GeoServer into a cluster like this. And one is, and I think this is pretty important, is GeoWebCache now is caching tiles for all these instances, and you can imagine that it's caching a lot of tiles. Probably it could be, gigabytes, terabytes, whatever bytes of data. And the problem is that the default block size for Red Hat is 4K. And I don't know what experience you guys have had, but we've had the experience that a lot of our tiles on average are much smaller than 4K in size. Usually they're less than 2K, in fact. And so what that means is if I have 100 gigabytes of tile data that needs to be stored, or say 50 gigabytes, it's going to use 100 gigabytes of space, because essentially I'm not using the entire block in Linux that I should be using. So one way to address this is just when you partition your drives in Linux is to partition them so that you have a smaller block size. This is a bit of a balancing act and not something you probably want to do on the drive that contains your operating system. But it's something worth considering and a way to address this problem of wasted space so that you're not essentially wasting half your drive space by having a block size that's incompatible. It's a balancing act, though, and it's something you probably want to experiment with. Some of the scaling and clustering obstacles that some of these have already gone over, but the capacity of your database server will circumscribe the capacity of your cluster ultimately. So it may not be the case that adding another GeoServer instance is really going to get you more capacity if you've already outstripped your PostgreSQL server or something like that. In that case, you're going to end up probably at first setting up some kind of a master-slave replication for PostgreSQL and then scaling your cluster out. Poor configuration. This can kill any cluster, and I've seen a poor configuration bring an entire cluster to its knees. That's same with poor usage. So poor usage would be the case where you're trying to display layers at too high a scale. We had a customer site where we were displaying, because of a configuration mistake, layers at 0 scale, which was causing the whole server to come down because it was just spent all day trying to draw these really huge tiles, or I guess they were small tiles or huge tiles with small data on them, and it was just gobbling things up. Network capacity will ultimately circumscribe it as well. Okay, so I wanted to give you guys some idea of what it looks like to scale a cluster in terms of performance. And so I did some really simple benchmarking, and frankly, I didn't get the machines that I wanted. I wanted to use Amazon EC2 to do some of this benchmarking. Instead, I got some really outdated laptops and my desktop computer. So I hope that this won't be completely useless to you. It might be, and just to show your boss and say, you should really give me some good hardware to use. I'm planning on showing this to my boss and saying that. But nevertheless, hopefully it'll be a little bit instructive. My home desktop was running Linux Mint 17. It's got a 8-core AMD, which is a bulldozer architecture, and 16 gigs of RAM. And then my first outdated laptop, I installed CentOS 6.7 on it, and it has an Intel quad-core, and has 8 gigs of RAM. And then my really ancient laptop, I also installed CentOS 6.7 on, and it had a dual core with 8 gigs of RAM. I didn't use GeoWebCache as part of this benchmark, primarily because I wanted to show you how much more processing power you might get from spinning up another instance of GeoServer where you're actually using that theoretical capacity with the load balancer. And so that's basically what I focused on here. I used 5 different benchmark configurations. The first, so on my machine, my desktop, I ran PostgreSQL 9.5 and Apache 2.4, I think PostGIS 2.2. And then on the really old laptop, I had one GeoServer and Tomcat container for the one GeoServer configuration. On the 2 GeoServer configuration, I ran one container on the old laptop and one on the ancient laptop. And then on the 3 GeoServer configuration, I scaled into the old laptop with 2 containers and still had one on the ancient laptop. And then when I had 4 GeoServer configurations, again, I scaled into the old laptop with 2 instances and scaled into the ancient one with 2. And then finally, for the 5 GeoServer configuration, I scaled in 3 times on the old laptop and 2 times on the ancient one. This benchmark, I put it together by basically taking a giant local access or access log from GeoServer and scrubbing the data so that it'd be appropriate for Apache JMeter. And if you guys haven't used JMeter before, it's really effective for submitting lots of web requests very quickly and getting some rough idea of the kind of capacity that your cluster or web server has. So I built that file, and then I built the JMeter configurations based on the configurations that I just showed you, the 1 through 5, and then ran JMeter over each one. And so here's the graph that I've got. And as you can see, the jump from 1 GeoServer to 2 is actually pretty substantial and kind of what you would expect in terms of additional processing power. The jump from 2 to 3 is less impressive, and I remind you, in that case, what we've done is scaled into the old laptop, so we've got 2 instances running there. So it's not that surprising that that hardware was going to be outstripped fairly quickly, and so we get a bump, but not a massive one. Same from when going from 3 to 4. We've scaled in twice now onto the ancient laptop, so we have 2 GeoServer instances running there. And again, we get a bump, but it's not all that impressive. And then finally, the wheels come off the wagon, and we scale in 3 times on the old laptop, and it's just too much for the hardware. And so it actually hinders performance to scale in that many times. I was very disappointed by this graph, given the hardware I had. I will say that it is instructive in one way, in the sense that I think it's a good good lesson. Adding capacity to a cluster, in theory, isn't always, or in theory is great, but it doesn't in practice always give you the performance you want. And one of the things that I've found is a big mistake is to go to a customer and say, well, if you just add this 1 or 2 more servers, your life is going to get a lot better. Because at that point, they expect their life to get a lot better. And so what I like to do, generally speaking, is to find some empirical way to see if I can actually make their life better before making that claim. So I think that JMeter and the techniques that I kind of just described to you are actually a really nice way of getting some idea whether scaling out is actually going to yield some performance improvement, whether you may have to scale the database server first. I mean, all those sorts of considerations are ones that you need to cover as an implementer before you go into a customer site and make promises that you may not be able to keep. So for me, this was good. I'm trying to turn my lemons into lemonade, but I think I did so here. Okay, so you guys have any questions? Go ahead, John.
How much of the performance out of that past 4 do you think was a result of blocking the database?
Sure. John asked how much of the performance degradation that I got when I scaled from 4 to 5 GeoServers was a result of database issues like request blocking or things like that. My answer to you is I don't know. Yeah, I don't know. What I do know is that when I looked at the hardware, I looked at the amount of usage on the RAM and the CPUs, and the machines were pegged. And not my machine, which was running PostgreSQL 9.5 on a fairly robust system, but these machines were completely slaughtered at that point. So I assumed that it was the GeoServer instances gobbling up too much of the resources. So. That's a good question. The question was, were these all point requests, WMS requests, for example, or was I using WFS or vector data? The answer is just WMS, no vector data. That's something I'd like to do, and I think, frankly, all this stuff would be equally applicable, but it's not something I actually worked on in this case. Go ahead. So the question was, did I think about using some other file system as opposed to ext4 for Linux in order to deal with the block size problem? The answer is no, not yet. It's something we could look at, and some requirements may drive that at some case. But at Ubisense, we have a lot of different approaches that have basically obviated this problem. One of the things we've managed to do is write a set of Python scripts that allow us to essentially read GeoServer data directly into a SQLite file, which if you have one giant file, then the block size issue goes away completely. So it's not one that we've had to address too often, but it's one that I wanted to mention to everyone else here because it's going to be an issue. And choosing either the file system or the block size is going to be something you have to consider. Go ahead. Correct. Yeah, I was serving the data through the data. So the question was, we are currently serving the data out of some database or rendering database points onto a map. The question was, have we considered serving this data directly from a file system? The answer is no. To some extent, it's because we're consuming data. In most of the cases where I've used this, we're consuming data out of a database, some external database. Maybe it's Oracle, maybe it's PostgreSQL. And what we're trying to do is build that GeoWebCache of files in a file system that we can then read. So to some extent, the architecture of GeoWebCache and GeoServer itself takes care of that for us and makes that a non-problem. So I would love it if a customer came to me with a set of tiles that they wanted to serve. In that case, I would just probably put Apache in front of it or something like that. So. The question was, to what extent did I tune the containers? I'm assuming in my benchmark. The answer is very little. I did change the memory parameters quite a bit in order to keep them from blowing up, because if you have your GeoServer Tomcat containers set up to consume more memory than you have on the machine, then something's going to go wrong at some point. That's primarily where I did my tuning. We do, obviously, when we go to customer sites, do a lot more tuning work and figuring out what the right scale is for GeoServer and GeoWebCache, the number of requests that we allow, and so forth. But in the case of the benchmark, it was a standard install. And to some extent, I think I can defend that by saying, you guys could replicate these results yourself by getting yourself your own crappy laptop or 2 crappy laptops and installing GeoServer and so forth. So yeah. Java 7, yeah, Tomcat 7. What's that now? Mark. Oh, okay. Oh, okay. Nice. So, anything else? It's on the website. Yeah, I think I've made one change to it, but it's they're all there. Yeah. So, all right. Well, thank you guys.